Greetings, Earthlings. Well, I've got the parts, the parts that I know I need for the Keithley multimeter here. Here is the replacement switch. You can see that. This is where the switch goes. That's the right pin spacing and everything. This is a, let's see, C&K is the brand, C&K F8UEE01A. And I got a keycap for it as well because the original keycap is missing. And the original was brown. This will be gray. It'll be fine. So I'll get that replaced, and we'll verify that that problem is resolved, and then we'll move on to figuring out what's going on with resistance measurement. All right, and so here it is, the new one installed. Perfect fit. The old one fought me a little bit, but I got it out, no problem. Didn't ruin any traces. Now I can see this old one, this was the bottom, was sealed on the bottom. The one I got is not sealed, which will make it easier, you know, if it needs cleaning, to spritz some deoxit, get it in there. But otherwise, it doesn't need to be sealed. And it has silver-plated contacts, I think. I don't know if these are silver or gold, but this one's broken. And I guess that's a fairly common problem with these meters, is that this particular switch fails. Okay, there's my button. Now, like I said, the original button was brown. I couldn't find a brown replacement, but a gray one. You know, who's going to know? Seriously, who's going to know? That's almost a perfect match for that. Size-wise and everything. So, let's see if that fixed the problem. Just going to put this on so I don't electrocute myself. Okay, so it's plugged in. We'll power it on. That still works. Come up in DC volts mode. Here's my output from my 343A voltage calibrator, set at 2.9 volts. This is on the front. I get nothing. I get nothing. Oh, there it is. Okay. Well, a little flaky. There we go. 2.9. It's happy. 2.899. There we go. Okay. So that's the front. We'll check the rear. I believe is this one. Oh, boink, 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 boink. Yeah, there's no input. I know that. So switch to rear. 2.9. Perfect. Okay. So, so that problem is fixed. Yes, it is. 29. I got a 290, right? Yeah. 300 volts max. Okay. Now, what about ohms? Ohms. Ohms. Well, there's something new. I just got this. Can you see that? Yeah, you can see that. Decade resistors, general radio, GenRad, 1433P, goes in 10 ohm steps up to 1.1111 mega ohms, rather. Megabytes. Oh boy. We'll do we'll do 2-wire for the moment. Go to ohms. I don't expect it to be any different. Okay, so 123.45, oh yeah, 0.123 megohms, okay? 0.1234. Now it's the next step that it didn't work before. And it still doesn't work. Okay, so I haven't, yeah, 240, okay. So, obviously that switch was not the issue on the ohms reading. So, we'll have to figure out what's going on there. Okay, here it is with the, opened up with the scanner card removed. And this is the digital board here. And it has a 68B09 processor, so it gets extra points for that. There's an EEPROM here, which presumably has the code for the processor, so I ought to dump the contents of that. All the interesting stuff is under there, though, so I'm going to have to dig into it. And this board, the digital board, gets its power and stuff off of these pins here, so it's not really going to want to run torn down. But I think the problem is going to be pretty simple to find, to resolve, because this is so it says simplified circuitry. There's a voltage reference here, okay, and then these resistors, reference resistors, which get switched in depending on the range. You would connect your resistance across here, okay, and then it's taking, and then it's measuring the voltage at, I guess it's at this point. No, it's at this point. Well, it's across that resistor. It measures the voltage across that resistor, and then it has known values up here, so it can figure out the ratio, and therefore can figure out the resistance. The thing that, remember, I wrote K1, this is K3. The thing, remember, that is different between the ranges where it works and the ranges where it doesn't is that K3 is switched in. Okay, so K3 goes through a what is that, PTC resistor, and so then there's a transistor connected as a Zener diode, basically. So my guess is, I mean, the first thing I'm going to check is Q16. I'm assuming it's probably bad, and so that when that gets switched in, the voltage here gets shunted to ground, and that messes up the readings. This is meant as a protective circuit in case you forget that you have it set on resistance and you measure, you put a voltage across it. That will that's supposed to clamp that voltage so that it doesn't damage the rest of the circuitry. Well, it looks like the rest of the circuitry is okay, because we can measure voltage okay, we can measure current okay, but it looks like when K3, where's my pen? I don't have my pen here. I'd fix that right now. When K3 is switched in, we're probably going straight to ground there. So I've got to remove this board, which means taking this panel off, remove this cover, and then on the back side, there's a panel as well, which needs to be removed. You can see the screws come through from the other side, but just to get at the pads to remove that transistor. So I'll proceed with that. All right, and here it is all opened up. that's K3 there. K3. I fixed it. K3. And, well, I mean, here's the layout, right? Q16 would be that one there. So that one's coming out. And I'll just check it with the ohm meter. Don't think we need to put it on the curve tracer. Yeah, I'm going to check it in circuit. This is a selected TG138, which is Keithley's internal part number. It's a GES5815 NPN transistor with an emitter base collector pinout. So the base is in the middle. The emitter and the base are connected together. It says, and but there should be infinite reason. So there should be I should see a short on one pair of pins if I start with the middle being the base. Okay, so that's basically a short across there, and this one is dead short across there. So that's probably the emitter. That's probably the base, or the collector. Try it in diode mode. 0.210 volts. Yeah, that's not so good. Let's reverse it and see what we see. Well, that's reading open. It's, oh no, it's not. Okay. Yeah, so it looks like that transistor may be bad. I am going to take it out of the circuit at this point. And here is Q16. And what I'm going to do is measure collector to emitter. All right, collector to emitter. There we go. But 270 ohms. Oh, that sounds familiar. That's in that direction. In the other direction, it measures about 270 ohms. So yeah, that's bad. I could measure to the base, but it really doesn't matter. 1.4K. I don't know if that's the emitter or the collector there right now. Okay, so now the problem is what to replace it with. As I said, this is a selected GES5818. GES5818. And then it's got the paint on it. Basically, a transistor acting as a Zener diode, the voltage will vary depending on the particular transistor. So they are selecting it for a certain voltage level, either a minimum or a maximum. My guess is going to be that it's about, it's got to be over 5 volts, because you could have 5 volts coming through here. But if you go over 5 volts on the input, that's when you want it to operate. Am I putting that in the right place? Yeah, okay. So it has to be north of 5 volts. I just don't know how much north. I don't have that particular transistor. Specs on that transistor, it's 40 volts VCEO and 750 milliamps. Constant current, constant collector current. If you hit it with 300 volts, and this thing starts at like 1.2K, it would be, I think I figured out about 250 milliamps. So I need something that can take at least 250 milliamps. This is 750. I think I probably have something. Okay, how about a BC337? That's 50 volts, 800 milliamps, at least according to what it says on there, with base in the middle. So I just have to get it around the right direction, and it should be fine. Now I have a bunch of these. There were 25. I've used at least one of them. So I can set up on a breadboard a circuit to measure their Zener voltage and see what it looks like. So let's do that. Okay, here's my setup. The transistor is here. Collector. There's a 1 k ohm resistor, which is fed from the power supply here. The base and emitter are connected together, and that's ground. And I'm measuring the voltage at the collector. And so let's give it 10 volts and see what we get. Well, this is not working at all. All right. Here is an actual Zener diode, an 8.2 volt Zener diode. If I put it in there, we'll see that, yeah, so it's got 20 volts in, it's got 8 volts out right now. It tops out around 8 volts. So, that works. Not sure why the transistor isn't working. Turn it around the other way, I don't know. Let's see what happens there. Okay, it's given me 10 in that direction. Of course, the first thing to try always is a 2N3904. And this has the right pinouts as well. Let me see. There's a EDC. Try it both directions, just like that other one. That's giving about 8 volts. Turn it around. Yeah, 8 volts. Okay. I'm gonna try this Zener diode and see what happens. Okay, so it's kind of back together. I didn't bother putting it all the way back together in case it doesn't work. I have it hooked up to that 123.45 k ohms of resistance. Let's see, it works. This is with the with that 8.2 volt Zener in place of the transistor. Switch to ohms. Okay, that's the 300 megohm scale, 0.123 megohms. That's correct. 1, 2, 3, 4. That's correct. Next range, 2.58 megohms. That is not correct. Okay, that didn't work. But it did change the behavior significantly. So that says that it looks like we've got more than one problem here. Okay, after much futzing around, I think I see where the problem is. Here we are on the 30 k ohm scale, putting 10k into it, okay? When I go to the 300k, notice it reads 40-ish. Okay, so it's about 4 times what it should be. When I go to the 3 meg scale, it reads like 200, it is around 300k. So about 30 times what it should be. Okay. This leads me to believe that the problem is with Q11. That this resistor, this 30K resistor, is getting put in parallel with the resistors that are supposed to be. Okay, so notice the yellow mark here. Let me see. On the 300K ohm scale, R17B and C are in parallel. Okay, so we should get like 1 meg. But if instead of 1 meg we get 30K, then that's about 30 times, right? No, that should be for the 3 meg scale. Wait a minute. Oh, right, because, I'm sorry. For the 3 meg scale, 10 meg in parallel with 1 meg, R17A and B, which gives you 1 meg. It's 30K. With 30K in parallel gives you about 30 times what you should get. On the 3 meg scale, no, on the 300K scale, I'll get this right, B and C are in parallel, so you've got 100K. And 30K in parallel with 100K gives you about 30K still, a little under, and so it's about 3 times, okay? U22C, according to the manual, U22C is closed for all ranges, okay? But Q11 is supposed to be off for the 300K and the 3 meg. All right, so I replaced Q11. I had some J112s, JFETs, which should be a suitable replacement for that part. And so let's now see what happens. I'll bring my resistance in here. I'll set it to 0. Power up. Go to ohms. 0 megohms. Very good. Let's go down to 300 ohm scale. Okay, 0.113. That's the leads in the, what would you call that? Latent resistance or whatever in the box. 10, 20. Okay. 100, 200. Okay. 1,000. That's overflow. We go to the 3,000 scale. Okay. 1,000, 2,000. Okay. 10,000. Go to the 30,000 scale. 10,000, 20,000. 30,000, yeah, almost there. Okay, 100,000. And this is where we had problems before. Hey, on the 300,000 scale, that appears to be working. Okay, crank it up to 1 meg. On the 3 meg scale, this also didn't work, and we're there, and we're there, and we're there. Okay. So I'm going to call this working once again. I just need to get it all back together and get the calibration adjusted, and it should be as good as, well, not quite as good as new. It was new in, looks like, 1989, but as good as can be. Okay, and here we are. I have it all calibrated. It's been up and running for several hours, as has the calibration equipment. So, we'll, oh, you know what? I should take it out of cal here. Okay. Yeah. So, DC voltage, I have it set for 2.222222. 2.222220. Okay. So, yeah, there it is. Okay. If I go to 22.222, oh, I want it auto range. Okay. 22 and plus or minus 1 or 2 in the last digit. I'll accept that. 222.222. Okay. And then if we go down to the millivolt scale, there's 300 millivolts. Pretty close. So yeah, DC calibration looks good. Let's go to AC volts. And this is at, let's see. You know, it gets calibrated at 500 hertz. So I'll set 500 hertz. This should be 1 volt. It's AC volts, good enough. I don't use this that much, AC volts. 10 volts. It's in standby, so that's why you're seeing that. There's 10 volts. And it'll take a while to settle down, but yeah, close enough. And 100 volts. Close enough. Resistance. Well, there's 2-wire and 4-wire. Let's go 2-wire and give it a meg. Here's 1 meg. Spot on. Okay, 900K. Let's bring it down to 300K. We'll go to the next range. Okay, and then that's pretty good. 3, 2, 1, 0. Yeah, and then on the what is it, 30K and below range is where they suggest 4-wire. So 3,000, 2,000, 1,000.